Hello, pre-calculus students. Our next chapter is on your old friend, conic sections. And before we get into coordinate proofs, I will first give you an introduction to conic sections. In the book, there's some nice illustrations of how you can get conic sections by actually slicing a cone. And when we do our section in 3D, we'll look at that in a little more detail. But for right now, I want everyone, to make sure you catch this video on how to use Geogebra in exploring the conic sections. So let's go to Geogebra now. And here we go, our algebra graphics view. One thing I want you to adjust before we get started is to go to the point capture, which is under Tools. No, under Options. Under Options, go to Point Capture and have it snap to the grid, so that you'll get whole number of points. It's going to make your equations with much more reasonable coefficients, and you'll see that in a second here. And let's put the grid on while we're at it. That's under Axes, View the grid. So there we go. And we can put some whole number of points in. And we can explore each one of these conic sections. The ellipse, the hyperbola, the parabola, and the conic through 5 points. Starting with the ellipse, we're told that we have to select two foci and a point on the ellipse. So we could select like the point 1, 2 and the point 1, 5. And let's put a point on the ellipse right here at 1, 6. And look at that, it whips up the equation for us. And that's what we expect for the ellipse. Now we're going to spend a lot of time in the chapter. Can you go from this equation and come up with a picture of the ellipse? But do try this and try experimenting around with moving these things around. These things are called the foci, so let's get them labeled as such. You click on it and you go to Edit Object Properties, and we want to call this caption, let's call this one on the left foci 1, focus 1, and have it show the caption. And let's call the other one focus 2. Point B is going to be focus 2. And have that just show the caption. There, I think I accidentally labeled this wrong. Yeah, sorry kids. Here, let's go like this. Click Object Properties. This is the one I want to have be focus 1. Here we go. And close. And we want to actually label this thing the ellipse. Should have just gone to rename. The ellipse. Okay. So there's our two foci and the ellipse. And notice what happens now when you start moving the foci apart. First of all, something strange happens there with C. See that? We can actually get an ellipse that doesn't have foci lined up horizontally. And as a result, you get this XY term. Okay? Let's actually slide these over so you actually get a constant term over here and so forth. But we mainly want to focus on these first three coefficients here. If I go ahead and move this focus so it's lined up vertically, notice we lose the XY term. But we have a slightly different emphasis on these two. And as the foci get closer together, you can see that these start in green until finally, if I put the foci together, they have the same coefficient, and we have what shape? That's right, the circle. So let's pull them apart again. There's focus 1 and focus 2. And we can also see with C, we get a nice simple equation there. What is C going to be? That's what we'll explore when we look at ellipses. And as C gets bigger, it also starts getting closer and closer, looking like a circle, as those coefficients on x squared and y squared get closer and closer to being the same. Okay, save this as your ellipse graph. Save as ellipses, so that you can just be ready to graph an ellipse if you're given the foci and a point. Now let's see how this changes when we look at hyperbolas. we go to our options again. We're still in the snap to grid and everything like that. Oopsie. Go to conic sections. Now we're going to look at the hyperbolas. And we can set up a point here at 2, 3. And maybe one at 5, 6, 3. Let's make it 8, 3. And then put a point down somewhere. And you can see we have all sorts of different kinds of hyperbolas here. Let's put a point right there. Now we'll explore some of the properties of this in a second. But notice how x squared and y squared have opposite coefficients. So it's when you subtract the x squared and y squared terms. And we can get our vertical hyperbola by aligning up the foci vertically. Again, let's get these labeled better. Let's rename that as focus 1. Okay, yeah, new name for point A. It's okay. It's not letting me do that. Let's just go ahead to object properties, and we'll call it caption focus 1. And let's call the other one focus 2. Object properties, focus 2. And caption. Okay. Looks great. And as we move the foci apart, see what happens to the conic section there. Still snap into the grid here. And notice we're going to review again what the definitions and so forth. And there's our points. Okay? So save that as, and have this ready to be handy, save as your hyperbola. So you're all set to go on that when you want to. Lastly, let's look at the parabola, which is very different. Make a new sketch. Parabola. Because in parabola we just select a point and a directrix, so we're going to have to make a line in here. So let's get something to quickly come up with a line. And let's put a line in here. Line through 2 points. There's our points A and B. And let's get this labeled and dashed, because this is going to come up a lot. We're going to call this the directrix, and we just want to show the caption. And let's change the color and make it a dashed line to emphasize the fact that it's not really part of the graph. It is a directional graph, just like the foci are not part of the graph. Now we also need a focus, so let's get another point out there. There's point C. Let's relabel this, or let's make it slightly bigger points. It's so key. Maybe we'll even make it open circle, because it's not actually part of the graph, as we're going to see. And have that match the directrix a little bit there. Good. Oh, but the labeling didn't work, so let's get that fixed. Let's get a directrix label like that. Object properties, basic. Yeah, we want, I said the caption. The caption is, this is the one focus. So we don't have foci, we just have one focus with a parabola. Okay, now we're ready to have it do its magic. And part of what we're going to do this chapter is where do these equations come from? So, for parabola we need to select a point and the directrix. So we select the point, the focus, and the directrix, and voila, there's our parabola. And you can start moving it around. You can grab the focus, move it to another point, and notice how the parabola starts narrowing. There's that vertex halfway in between the focus and the directrix. And as we start going further away, and notice as we come below, as the focus comes below the directrix, now the parabola is going down. Okay, and here's the other cool trick, is we can start messing with our line. Well, and notice what happens with the formula. You start getting XY terms. When it was just a horizontal directrix, we actually get a vertical parabola, and you just have the x being squared. If, on the other hand, you line these up vertically, now you have a vertical directrix. That means a horizontal axis of symmetry, and we have the horizontal parabola where the y is being squared. Okay, let's definitely save that because we're going to have more fun with parabolas later on in the chapter. So we want to save as, let's call this one parabola. Okay. Now, there is one more thing that I think you're just going to find hugely fantastic. And that is the last thing we have on here under conic sections, and that is the conic through 5 points. You select 5 points, and it will basically tell you the conic through them. Okay, let's pick 5 points. Now notice it's snapping to the grid. That's nice. 1, 2, 3, 4. Oh, it's not going to be able to handle this down here. Oh, but it did. Now hold it. That doesn't look like a conic, Mr. Lang. Well, I think you'll see that it's a degenerate conic. Wouldn't you know? What my luck. I came up with a degenerate conic right away. If you slice a cone right through the middle where the two naps come together, you would actually get this big X-type shape. Now, is it really a big X? Let's zoom in on that section to see if it's a big X or if it's actually, yeah, it looks like those lines are crossing. Yeah, so let's just back up and zoom out again. Zoom out. Get back to that scaling we had before. Something like that. Okay, cancel. And I think I want to zoom in actually a little bit because we kind of lost our, there we go. I wanted our points and whatnot. Well, how can we fix this? Let's try moving this around here. Oh, grab the point, move it around. Notice that's also generating the equation too. Blink. Now you've got something a little more familiar, right? The ellipse. Maybe we can move this around a little bit. Can we get it to be a circle? No, just another ellipse like that. Oh, there's hyperbola now. Blink. Can we get the parabola? The parabola. Oh, there's our degenerate conic section again. And it could be as a result, because notice when I drop E here, I've got 3 points in a line. And if you've got 3 collinear points, there's no way you're going to get a curve to go through those. Well, I just learned something. Okay. And look, by keeping those 3 points like that, there's no way I'm ever going to get a regular conic. But apparently this is a degenerate conic too. Now, I don't know how you slice a cone and get 2 parallel lines. But if we just move this a little bit, oh, now we've got the parabola, hyperbola again. Where is our parabola, friend? Well, we can certainly make a circle if we get things spaced out just right. Let's get this over here. There. Is that a parabola? No. Is that a parabola? No, I got a little section there. So what if we go like this? A lot of people mistakenly think this is a parabola. Oh, be careful. Move this around and you can see, oh, maybe it is a parabola. Yeah, I don't see there's a section there. Oh, we got pretty lucky there. Okay. We've got our parabola. I'm not so sure though. Is this really parabola or hyperbola? Well, zooming out can really help. If we zoom out a bunch of times, is there another branch to this? Then it's a hyperbola actually, right? Let's take a look. Zoom out bunches and bunches of times. Certainly looking like a parabola. Oh, no. See that? It was a hyperbola. Boy, parabolas are tricky because we're going to see later on that they're on the boundary between hyperbolas and ellipses. So let's zoom back in and see if we can't fix this. Or, because it's kind of hard to grab points now like this. Zoom back in. There we go. There we go. And one way you can make sure you get your parabola is pick points that you know aren't a parabola. If we just scooch this guy over to the old over 1, over 1, up 1, over 2, up 4, which you're used to seeing. See, so that's a hyperbola yet. But now suddenly this is your parabola. And notice what's happened with the equation now too. We don't get the x squared and y squared term. We just get the x being squared. Now that doesn't mean a parabola has to be vertical or horizontal. You can twist these parabolas as well. Like, let's see. If we kind of rotated all these, would that be possible around a big circle? But you can see there's lots of ways to play with this. Do you suspect that that's a parabola or a hyperbola? Or maybe even, you got it. Are you reading my mind? It's a really long ellipse. Okay? So, have fun with that, and flange out. Security lane.